This episode of Total Network Operations is sponsored by Meter, the company building better networks. Meter delivers a complete networking stack, wired, wireless, and cellular, in one solution that's built for performance and scale. That includes everything: ISP procurement, security, routing, switching, firewall, wireless, cellular, power, VPN, SD-WAN, multi-site workflows, and more. Go to meter.com/TNOPS to book a demo. That's meter.com/TNOPS. And now, on with the show. Welcome to Total Network Operations, the project with a podcast dedicated to hardworking network operators like you who deliver all the packets. Our mission is simple: to bring out great ideas in NetOps. I'm your friendly neighborhood podcast host, Scott Robon. And today, I have a great friend and industry heavyweight joining us today, Kireeti Kompella. I think Kireeti defies introduction from me, so let's just jump right in and we'll let Kireeti kind of lay out how he got to where he is. Kireeti, thanks so much for being here today.
Oh, happy to be here and happy just to connect with you again. How did I get here? I was in storage. And I'd come up to the Bay Area. I was working with Silicon Graphics. So I'd come up here, did an interview with them. So I was at SGI in the XLV, the logical volume group. I went from there to Network Appliance, and that's another storage/file system company.
Right.
Doing really well. Had really nice chats with Dave Hitz, who's the CTO there, who was the CTO there. But then a colleague of mine at Network Appliance said, "Hey, there's this little company, this stealth startup. You should go check it out." So I said, "Sure." I went, checked it out, did my interview, and they said, "Hey, they made me an offer." So I come back to this guy all excited. "Hey, they made me an offer." And he said, "Great. Tell me how it works." And I'm like, "What? Aren't you going to jump in?" And I said, "No, I'm not that nuts. It's a tiny startup. How is it going to work out?" And I'm like, "You just threw me off the bus? Is that what you did?" It's a great decision. He and I are great friends still. So that's how I ended up in Juniper. I ended up in the Kernel Group because that was my background.
Okay.
But I went to my boss and said, "I want to get to a protocol." So he said, "Show me what you can do, and then we'll find a place for you in protocols."
Well, clearly you had an impact in the protocol space. And, why don't you, what's the highlight reel for contribution to networking protocols that are the biggest ones that stand out for you?
So when I got into this protocol side, actually a little before that, coming from a background of doing computational number theory, a PhD, theoretical computer science, I looked at our lookup algorithm. We were building chips. This was a big thing, that we were building chips for IP forwarding, where everyone else was doing IP forwarding and software.
Sure. And
I was able to improve the chip performance by 30%. It's just algorithmic. It's nothing to do with, we should redesign this chip or something.
Sure.
Here's an underlying algorithm. Let me tweak it. And so my name is on the C chip patent. Like, well, okay. That's nice. Yeah.
Oh, very nice.
So that was one step. But then I was still in the Kernel Group and playing with those things. And then they say, look, there's this effort to bring, all these networks are ATM and frame, and we want to bring them into the IP world.
Right.
But to do that, we need drivers so that we can connect ATM cards to our box.
Sure.
We can connect. And so they said, go do those drivers. But then they said, no, we don't want to necessarily have, be running an ATM network. So maybe we leave ATM at the edge. And I want that ATM to ride over something across the network.
Right. Imagine that, right? Coming from the 90s, right?
Right. Yes.
Yep. And I was a 4 systems instructor for ATM very early on. Yep.
Yes.
So
So we said, look, we have a protocol we want to run in the network, but you got this ATM on the edge. So how do I put ATM on top of whatever it is we're running? No secret that what we were running in the network, of course, there's always IP, but we were running MPLS. And they said, can you take ATM packets or ATM cells, put them over MPLS, carry them across the network, and deliver them? And the far end should never know that it actually was, emulated, and it's like native ATM all the way.
Right.
And then why just ATM? Why not frame relay? Why not PPP and so on? So essentially, I came up with how do you carry layer 2 over MPLS? But that was done very point-to-point kind of way. Oh, you are this circuit. I'm gonna cut everything in the middle and give you an ATM, an MPLS LSP, and your frame relay connection will be there. But then people said, but you don't do one or two at a time. Someone has 20 such connections. Do you want to do each one by one? I said, okay, step back. Let's talk about VPNs. This is a virtual private network. It happens to be layer 2. I have a model for a virtual private network that runs at layer 3, BGP, MPLS VPNs, RSC 4364. So I said, let me take those concepts over. That was a lot of fun. That was also I did everything down to BI microcode. Our chips were very cleverly named.
B chip in, right?
Yeah,
the B chip input side.
Exactly. So we had A, B, C, D. The C chip is the one that does the lookup, and B does the input and output processing. Right. So BI microcode to recognize the packets that are coming in, saying, "Oh, your ATM, I need to do this to you." BO to say, "Oh, I need to put an MPLS label." All of that microcode I did. So it was a really fun project. But externally, there are these people from Cisco and a whole bunch of other people. It's not just Cisco, but they all said, no, you should be using a different protocol for that. But I said, no, I'm using the protocol that does BGP MPLS VPNs, and it starts with BGP.
Right.
And so that became a hotspot for quite a while. Of course, in the end, what happens after telling me, I don't know how many times, BGP is for layer 3 and above, and I'm doing layer 2. But and I was just doing configuration of this, right? In the end, we have EVPN, and you're actually carrying MAC addresses in BGP. So what
is an NLRI type? What is an NLRI type? And what is the elegance and the separation of the protocol machinery and the ability to just deliver another, let's create a new NLRI type. Like I've always, and like that was a fatal flaw of like OSPF compared to the separation in BGP, right?
Right. So, yeah. And multi-protocol BGP. Did that ever occur to you? Yeah. So it was fun. There were these arguments, and of course, being the smaller player, we got stepped on a lot. But like I said, the ultimate vindication is EVPN, which now everyone wants to do.
Yeah.
It's not just you're carrying configuration of layer 2 VPN, you're carrying actual layer 2 addresses in BGP. So
that's amazing.
So that was fun.
That is amazing to me. So a couple things to pull on there. So we have a connection that I did not realize. Being on the other end of the engineering spectrum as a TAC engineer, I think I have the claim to fame of discovering, I think, a BChip 2.0 bug that resulted in a respin, where if you had like a T1 and an OC3 coming into the same FPC, if the T1 was running at line rate, it would prevent the higher rate ATM circuit from running at line rate.
Interesting.
So, and we can blame, I mean, credit France Telecom for that. So.
Oh yeah. Yes.
So you inserted the bugs and I found them. Just kidding. I'm not going to blame you for inserting that bug.
Well, we'll come to my bugs later.
Yeah, for sure. The other thing, I want to park on the hardware discussion a little more here, but one thing I've kind of always assumed, and I think I picked up early on, was that, throwing hardware at the packet forwarding problem and the lookup problem in particular. One of the justifications I've always heard, or the rationales behind MPLS, is that you have fixed link labels. You don't have a mask. You have an exact match for a label, and that was computationally less tedious than doing best match lookups for IPs with. Is that accurate? And can you expand on that at all?
So I think there are two pieces to that. MPLS is definitely efficient. And you're right that people did MPLS to make the packets go faster. So because layer 3 routing was at best DS3 at the time, and people wanted to do OC3 and OC12 and OC48, and ATM had already reached, at least as a prototype, they were doing OC48.
Yeah. We had OC192 support at some point as well.
Yes,
and this commercial growth of the internet, your mom getting an email address, right?
Right.
And even your grandmother maybe. Now everybody and the point, thank you, Mark Andreessen and Netscape, and the point and click interface for the internet just drove demand. And so we had to do this. We had to.
Yeah, we had to. So we said, okay, but we want to work at the IP layer. So how do we do this? And one idea was to map IP into a layer 2 thing. And so there was a company called IP, I forget the name. Dennis came from them. Dennis Ferguson.
Yep.
Yeah. And so they said we'll map an IP flow to an ATM VC.
Mm-hmm.
Bad idea because of way too many flows. So just take an IP address, and as you said, do the best match lookup. And that was Pradeep's idea. Pradeep being the principal founder of Juniper. He said, I can do this in hardware. Yes, it's more complicated, but it can be done.
Sure.
So the point here, I think where you're going, where we're aligned on this is, we can have specialized hardware, and that specialized hardware really, really helps.
Yep.
So you have specialized hardware. First you have a general purpose CPU. Yes, I can do a lot with that. But now I want to do this packet forwarding. So I have specific functions I need to do, extracting fields, looking up those fields, doing best match lookups, doing other kinds of lookups, doing those lookups really fast. Then you have, of course, the graphics. Now today, graphics has gone nuts. And it's not really graphics as much as I can deal with a matrix really well. My architecture is optimized for dealing with matrices.
The underlying math that the chipsets are optimized for. Yeah.
Right. If you want to get fancy, call it tensors, but yeah, sure.
Yes. Yeah.
And then you have specialized chips for dealing with Wi-Fi or dealing with radio signals. And then people say, I can put all of these chips together. So you have a SoC, system on a chip.
Mm-hmm.
And yes, you need software on top of that to do the final bits, but the heavy lifting is done in the chip. So I think we're both aligned in that we need chips, we need hardware, and the specialized chips really help us.
Right.
And the fact that software is more flexible and can do better things or more complete functions should not distract you from the fact that these hardware is so useful.
Yeah.
And I think
it becomes buried and assumed, right? The chips doing that heavy lifting. Yep.
Yes. But in the end, you need them.
So let me parlay that into, we saw this incredible growth and scale and next gen of that forwarding chipset. Of course, Juniper had its version. Other competitors, other players in the space also effectively built silicon to do similar things. And then in 2012, 2013, this browser guy, this HTML guy starts talking about software eating the world. And that hit us in networking with the advent of software-defined networking. So, being on the product side, software and hardware work together. Last time I checked, software runs on hardware. What was your reaction to that whole trend?
It's actually a multifaceted reaction. First of all, yes, as you said, software is everywhere. But if I just look at the numbers, 84% of, at the time, 84% of Juniper engineering was software, 16% was hardware.
Sure.
95% of Juniper revenue was hardware.
Right. Yep.
So, but of course, that hardware is useless without the software. So
Right.
it's just that we didn't monetize the software, and people were accepting that. So there's this funky sort of interaction. But in the end, what's important is the hardware and software work together.
Mm-hmm.
The software gives you things that hardware can, it's much quicker to do things. It can give you these new features,
More
provided
fungible.
supported.
I can recompile. Yep.
Yeah. But hardware gives you things that your software will never get to. So today, we're running at 400 gig, 800 gig. We're moving on to a single interface, single port, doing 1.6 terabits.
Yeah.
No way you get anywhere near that with any kind of software.
Right. Yep.
So, and it's not just that it can go so fast. I mean, you can filter at that speed. You can look at packets coming in at line rate and say, I'm going to encrypt them, or I'm going to analyze them and drop them. All of that, you need that specialized hardware. So if you focus on one thing at the expense of the other, you're not getting a full picture.
Yeah. It's a system view. It's maintaining a system view of what functional blocks are accompanied by which pieces, or what functions are performed by different functional blocks within the system.
Right.
And we do see a little bit of a resurgence today in that, Jensen helping make hardware cool again, right?
Yes.
To the advent of the GPU, but just to your tip of the hat to TPUs, from Google
XPU.
and yep, exactly. It's all interesting, and there's still innovation happening there.
Right.
But there was a point in the mid-teens where you had a mission to actually repurpose the SDN acronym, and you used it in a different way. Well, how did you accomplish that?
Well, let me give you a little bit of a history or background to that. So I started as a protocol guy. I mean, I started as kernel. I moved into doing this stuff. I told my boss I want to do more protocol stuff, and he said, "Oh, go do this VPN thing, and then go do MPLS." And I did a lot of MPLS, and I was sort of in that layer, sort of on box. What can the box do? How can we get new features on the box? But as part of my VPN thing, layer 2 VPNs over MPLS, I learned that provisioning is important. Operations is important, and so get away from looking at the network blocks at a time. So the expression, you can't see the forest for the trees. I couldn't see the network for the boxes, so I stepped back from that.
Sure.
And I started looking around to what else is happening, and this provisioning and kind of getting a holistic view of the network, and able to provision a service which of course involves multiple boxes, look at the network and say this thing is running well, but that thing is not. This service is going well, that's not. So that whole thing started making me think about, okay, so provisioning and monitoring, all of this is really important. And I'm doing this while I'm sitting at a red light, and there's an oncoming car doing a left turn in front of me, right?
Mm-hmm.
Protected left. This is the Bay Area. In LA, you don't have protected left. So I'm sitting there like, how does this guy know that there's no one oncoming from the other side? There's no one, no pedestrians crossing.
Sure.
Wait, you've got enough automation. It's beyond automation. You've got the self-driving capability in this car. And here we are managing our networks manually, trying to understand how to provision the service, seeing if you got it right, monitoring the service. Like, why are we doing so much manually? And so I said, we need self-driving networks. And then it hit me at the same time. I was seeing a self-driving car, so I just mapped that over to networks. But it hit me that I could repurpose that acronym that was so incomplete in so many ways. To an acronym that's far more complete because you're encompassing everything in operations.
Yep.
And so that's where that started. And that was back in 2015.
Yeah, and I remember the big public presentation in 2016 at one of the Next Work, right, was the name of the title
There
of
were
the
two
series. Yeah.
There's Next Work, which was towards the end of the year, and there was the MPLS conference in Paris, which was in March or April. So there was two, and I did several. At the time, I was like, "Whoa, I'm onto something here."
For sure.
Yeah.
So it's, in a sense, there are people who say they've been doing network automation even since the 80s, Perl scripts, right? And they're not wrong.
They're not wrong.
And I think I want to, see what you think about the following. As I've zoomed out even further and done work with Network Automation Forum, there does seem to be a lot of focus on automating the operation around this router or this switch, whether it's, I'm still using Perl or Python, or I'm moving towards Go. I wonder if, that self-driving network idea, we kind of defaulted into a self-driving router or self-driving switch or self-driving firewall.
Right.
And the self-driving network is more like the traffic management system for a given metro, area, for the Bay Area or for the LA area, right?
Yep.
And I know, so peel that apart a little bit. Like, what do you think about that broader level set of issues?
I mean, I think I looked at the self-driving car and jumped from that to, you can do so many operations within the car. There is this huge thing where the car has autonomy to make decisions, go straight, turn, stop, slow down. And
just a tip of the hat to that too. Like now getting into Waymo is easy. A friend of mine just did this with his grandkids last night, right? And we can conceptualize that, but when there are thousands or tens of thousands of cars, that is more like, how do I manage the autonomous operations of this network with hundreds or 1,000 routers and switches or more?
Right. Yeah. And so at least in one autonomous system, you can say, I can have a central controller that will do this for that, at least for my network. And then you can do yours for your network. And then we'll have a boundary where we'll have to talk.
Sure.
We've always built networks that way. So that's not a huge deal. So, but I think the big step was autonomy. And so to go back to what you were saying, I have a man with a spade and he's digging away and trying to make a hole to prepare the foundation. And then over there, I have a lady in a bulldozer and she's doing 10 times the amount of work in half the time. Right. And so automation is like, I'm going to give you that kind of power, but it is still a human driving.
Right.
And then you have this mythical device, which is a self-driving bulldozer that you just say, by the way, here are the boundaries of the hole I want. I want it like 5 meters deep. And then you walk away. And that's a step jump. And so for me, that going from automation to the autonomous self-operated automation was a big step. And while people have been doing automation for a long time, self-driving networks, we made little bits of progress. We can do a few small things. For that matter, self-driving cars, we realized how big the problem is. There was a contest in 2004 or something.
The Grand Challenge for
yes.
Paul Mankiewicz talks about this all the time too, or at least he used to.
And in my initial presentations, I used to start with that because the first time they ran it, everyone failed. The second time, they got a few people to succeed. Right. But from there, they said, in 5 years, we'll have it. Well, it's now 2025, it's 20 years, and we still don't have it.
Right.
And yes, there are a lot more complexities and a lot of legal issues, a lot of safety issues. But having said that, it's more than that. It's the step where I take away, in some sense, I take away your autonomy, or if I turn it on myself,
human autonomy. Yeah.
Human autonomy. I give up my autonomy. I let the car do it.
Yeah.
And then I realize how many things I'm thinking of at the same time in order to drive the car
That's
or
right.
run a network.
Yep.
And so it'll take time, but we've made huge progress. And I think it was the National Transportation Safety Board had these 5 levels of autonomous driving.
Yep.
And the last one is you don't even have a steering wheel or pedals.
Yep.
But there were things in between where you can relax, you can keep an eye on things, but all the fatigue, especially of long distance driving, is vastly reduced. We can do the same in networks, where the network will look at what's going on, analyze it, tell you this is working well, this is not. Oh, here's the root cause for that. Here are 3 things I suggest you do, but won't actually do it.
Right.
And I think
keep the human in the click OK to continue loop. Yeah.
Right. Exactly. Yes.
Yeah.
But then, of course, the big buzzword today is agentic AI. And agentic AI.
You make your comment, and we'll come back to that. Yeah.
Okay. Yeah. I mean, agentic AI. The short form is you give agency to the AI. So you like jumping forward.
Yeah.
And we'll come back to that. Yeah.
Well, so maybe this is the right path to that, or at least a possible path to that. And so thinking about moving toward autonomy, one of the models that I've been thinking about lately is basically getting protocol-like behavior across an enterprise network or a carrier network or a hyperscaler network. And, again, feel free to correct or modify anything I say here. But if I think about, all the use cases that protocol developers have had to think through and accommodate for RSVP with path and reservation messages, right?
Yeah.
Or through the BGP state diagram and the hellos and keep alives and other mechanisms where I figure out where I am in my state relationship to other peers. John Moy doing the hard work of, okay, what does it mean to form an OSPF adjacency, right? That didn't happen overnight, right? Some of it happened in committee. Some of it happened, probably not much of it happened in committee. Probably it was, whether it's on the back of a napkin, right? Or I had an aha moment on, how to say I have an established adjacency. You thought through workflows in a sense.
Yep.
And I think there's an analogy to that, to thinking through the workflows within an enterprise network that might have disparate equipment, that might have weird, cul-de-sacs at different branch locations. But I think that's a key to seeing more adoption of autonomy, working through the workflows so that I can simplify, templatize, and actually get to protocol-like behavior. That's a lot. I'll stop and breathe.
Good. No, that's a really good point. And I think it brings us to a big dichotomy between, say, a transport network, where, ATM, frame relay, or optical. And ATM did bring in protocols, and an IP network, IP MPLS network, which is all protocols. Right. And the big thing there is, do I have centralized control or distributed control? And if I have distributed control, how does that work? And so now I have all of these autonomous pieces, but they need to share state, and they need to have a common understanding of that state. So whether it's a BGP message or an RSVP path message, or whether it's an LSP or LSA from OSPF, these are elements where you're trying to achieve distributed consensus on the state of the network, so you can all do the next thing relatively in sync. As opposed to the centralized entity that will, I know all, do all, and I will tell you exactly what to do.
Right.
And there's good and bad in both. And this was another aspect of SDN that I did not like, because it started with the software thing. But And then it said, the network has to be centrally controlled. And I said, no, we've built networks distributed for a reason. Actually, ARPA back in the day said, I want to build a network. And if you take out a router, you take out a link, you take out even a city, the rest of the network will continue operating.
Yep.
So there is no single brain that you hit it and now you're all done.
Fundamental design assumption that became obvious in the 60s, right?
Yes, totally, yes. Having said that, there is some value to centralization. So if you want to do global optimization, if you want to do coordination, it is easier in a central thing. So it's not the case that everything should be centralized or everything should be distributed. Pradeep and I would have these arguments about centralize where you can, distribute where you must. Well, that was Pradeep. And I was like, distribute where you can, centralize where you must.
Right.
And so as much as possible, have a distributor, but those few functions that makes more sense to have centralized to get the coordination and all. And I think this is part of what is happening here. In the end, if you have a mechanism where I can control the network, I can get enough information from the network, that getting all the information and analyzing it and trying to figure out what's happening is generally more centralized. But then if you say, okay, now I can see what's happening and I have a way forward, I need these 20 things to happen, I can distribute those out. And in distributing those out, I can use existing protocols, I can create new protocols, but that is a distributed operation. Yeah. So this mix of central and distributed, anytime you go one way versus the other, like we said, if you say everything is software, like now you missed out the bigger picture. Right. If you say everything has to be centralized, you're missing out. If everything has to be distributed, you're missing out. And I think here you have the same thing, that I could have a central entity that is doing all the computation that is necessary to understand what the network is doing and what the network needs next. But then the actual implementation of that could be distributed.
Yeah. And if I do like that model. And I will just state for the record, I have a strong anti-controller bias. Like, the reason we were able to scale and have been able to scale the internet to the scale we have today is because of, there's a reason we call them autonomous systems in BGP. Right. You can do what you want in your network, Kireeti, and I can do what I want in mine. As long as we define the interface, we're good. Right.
Yes.
And I can theoretically give philosophical assent to the idea that maybe there's some good place for some controllers somewhere. Your example of data collection and intelligence gathering, that makes a lot of sense, but I don't think I'd call that a controller.
No, it's not. It's not a controller yet.
Right.
So here's what happens: you gather data from lots of places, you bring it to one place. There you can actually do correlations and say, oh, there's a traffic spike there, but there's those people that have just put out a new CD, or they've just released a new CD,
or a Microsoft Windows update. Yeah.
Right. Yes. And so you can correlate that, and then you can say, okay, this is what's happening. And then you can make decisions around that. And even those decision makings can be centralized, because you don't want everyone to stop doing whatever they're doing because your network stops. You want to say, you need to slow down that, and these guys need to slow down how quickly they're absorbing these new things, and the rest of it can go on. So I think you can make centralized analysis and centralized decision-making and distributed action. Because now if you say the central entity has to go and do all of these changes and change the filters here and change the traffic parameters there, that's going to be a bottleneck. Yeah.
So you've made me a lot more comfortable with that split of responsibility. I think I like that model. And if I think about
it, took me a while to get there, because I was like, everything needs to be distributed.
Yeah. No, and look, I think that brings us to let's revisit the agentic AI and AI entering the room conversation here,
Yes.
where so some of those centralized analysis tools, the phrase digital twin comes up very often now, and I don't think it's just a buzz phrase, right? I think there's now real ability to
that was my
gather.
first talk at your AF0.
That's right. That's right. At AutoCon 0, November 2023. Listeners should go watch that. And thank you again for doing that, for that inaugural event. But I can do this with network information, with node and link info. But I have the ability to bring, I can span technology domains, let's just not say frame relay or ATM for the rest of this conversation, because it doesn't matter anymore. Sure, it matters somewhere. But I can take optical info, alarming TL1 information, and combine it with syslog and SNMP and streaming telemetry from IP components. Boy, I could also wrap in security alerting information.
And social media updates. That's right. You mentioned that in one of our previous conversations. Yeah. And maybe even tying it to application performance. Yes.
What if I could look at what Datadog does along with my streaming telemetry and my optical and my SIM? This control plane 3.0 is the phrase I'm trying to get the industry to use, right?
Yeah.
How close are we to seeing real leaps there and spanning boundaries where we've had reasonable separation before?
Yeah. I mean, the phrase, I'll come back to your agentic AI for a second. I think it's an overused buzzword right now.
Sure.
Literally, it just means giving agency to the AI.
A software process that has some guardrails to make some changes in some way.
Yes. But the thing that was recognized in creating that, and the associated buzzword is MCP, Model Control Protocol. It was that there are these silos, and for various reasons, you might not want an agent to have full control of all silos or full access to all silos.
Sure.
So I need protocols between the agents. So I'll have an agent that will sort of look after my database of what services are in my network. I'll have another agent that is looking at all the telemetry that's coming from the routers. Another agent that's looking at going back to social media. And then these agents can talk to each other. And they don't have to share everything about everything, but they'll say, hey, this is happening here that might be relevant to you. And that's true. Do you see this also happening? And so those agents talking will get to a place where they'll say, okay, we think we understand why the network is behaving the way it is. Then comes in the other aspect of this, which is the agentic AI, which is that I can actually do something with it. Otherwise, I could say, here's my analysis, here's 3 or 4 possible root causes, here are 3 or 4 possible actions you can take.
Yep.
Mr. Robon, you pull the trigger, right? Because, but if they do it right for a while, then you might say, okay, in this context, in this kind of situation, you've been doing well enough, go for it. It's almost like you have a trainee and you're saying, okay, you've reached a certain level.
Right.
Yep. And so I think, to your point, this boundary spanning can be done by having agents in each one that basically says, I'm going to look after this domain. I know this domain pretty well. I'm going to respond to questions from other agents saying, are you seeing a surge of traffic, or are you seeing a lack of traffic? Maybe there's a DDoS attack, maybe there's a black hole sync. Are you seeing, and so you ask different questions, you get the answers, and then sort of these agents pooling together come back and say, I think this is what's happening.
Sure.
And that's the first step to trying to figure out what to do. And then the next step beyond that is to actually do it.
Right.
So I think this very important thing that you bring up, whether it's optical and IP, or my autonomous system and your autonomous system, or it's social media, they are separate. They will be separate. You're not going to ever have them all in one. But if you have an agent or a set of agents that take care of each one of them, and those agents can talk, I think we can get the right information and the right processing.
Let me tell you a bit more about Meter, the sponsor for this episode of Total Network Operations. Businesses are frustrated with unpredictable pricing, IT resource constraints, complex cost-prohibitive deployments, and fragmented tools. This makes it difficult to achieve the performance, reliability, and security that modern IT and operations demand. Alongside their partners, Meter designs, deploys, and manages everything required to get performant, reliable, and secure connectivity in a space. They design the hardware, build the software, manage deployments, and run support. It's a single integrated solution that scales from branch offices, warehouses, and large campuses to data centers. Meter's full stack solution covers everything from the first site survey to ongoing support, giving you a single partner for all your connectivity needs. I've seen it up close, and you can check it out yourself. Go to meter.com/teenops and book a demo now. That's meter.com, meter.com/TNOPS to book a demo. I highly recommend it. I think you'll be impressed. Thanks to Meter for sponsoring this episode of Total Network Operations. And now back to the show. I think that's a great functional assignment where it actually fits. Human developers are going to be instantiating agents, right?
Yes.
And, agents have agency in a limited context.
Right.
And I can take the optical engineer and say, well, there are agents that can do pieces of the optical engineer's job. Notice I'm not saying replace the optical engineer, right?
Yeah.
But the same for the IP engineer, and it's not fair to just call that one domain. There are all sorts of other, smaller agents or sub-agents that would do things. Same for security info, same for application performance. We have, we can think back to the Unisphere Session Resource Controller and that whole conversation. But I feel like we've got the power tools to be able to analyze that information together in ways that we haven't before. And that's actually pretty exciting to me.
It is exciting. Yeah. And on top of that, we have the underlying tools that allow us to really analyze data.
Yeah.
So
exactly.
It's one thing to say, you're the expert on this data, he's the expert on that data, she's the expert on that data. And now we can talk and we can hopefully ask the right questions and then come to a consensus about what is happening. But to do that, there's a ton of data under the covers. So even though you're the IP expert, I come to you, you want all this data from your network to be analyzed and given to you as, here are the top 3 things you need to look at. Yeah. And that power is also given to us now with LLMs, with transformers, with the ability of the new, the advances that we're making in machine learning,
right,
to do that analysis.
Yeah. There's so much underneath the surface in terms of, ChatGPT and other chat tools kind of take up a lot of the oxygen in the room.
Yes.
But different models do different things. They're not all large language models. They can be small language models.
Yeah.
ML is still advancing and is yet another flavor under that umbrella. So as I think about, making incremental progress, because that's usually how progress is made, building trust is inherent to the adoption of any new technology, right? And that's not new for anything, star.ai.star. It's you saw it with MPLS adoption, right? You've seen it with and even just plain old trad network automation, right? You got to go through a process where, the tools do what I expect them to do reliably. So anything special about this next era? Or we just have to apply the same principles in this context?
So I think the two very different questions that you just asked. If I take your question in the context of networking and automation and self-driving and so on, I think we can keep making progress. I think we can start understanding which tools to apply where and what results to expect. And now everything falls under the bucket of AI, but I could use even statistical tools to say, is this an anomaly, or
Yes.
what?
Yes.
Where does this graph tend to? You know,
The old tools don't go away.
Yeah.
They're still, and they might even be more cost effective, right? I'm adding new tools. Yeah.
Yes. But the only small marketing change I would make to what you just said is the old tools are also ML. They're all machine learning.
Sure. Let's call them ML. That's fine. I can sleep on with that. Yes. Yeah.
Yeah. So we are inventing or creating new tools, and some of them, as you said, is the LLM. Some of them are the smaller LLMs, but also the refining of an existing LLM. So I think that's all helpful. The trust part is where you say, do this, or tell me what to do. Do that 50 times, and if all 50 times you get it right, I might let you do it on your own next time.
Right.
The guardrails are the ones that are missing, and we don't really know how to do guardrails. And I don't mean for AI itself. I'll get to that in a second. So I just gave you this bulldozer, and I said, dig a hole that's 50 feet by 50 feet by 10 feet deep, and you did wonderfully. And then I put you on a different plot, and there was big stones in there, and you dealt with it, and I put you somewhere else. So great, now do it on this particular plot, and the bulldozer goes haywire because there's a house standing right next to that plot, and take the house out. Okay, what did I miss?
Right.
So that's the kind of thing that you test things in order to test. You visualize this could go wrong, or and where that vision falls, where that vision has a blind spot, the AI could just go off and do something that you didn't expect, and the consequences could be pretty bad.
Sure.
So yes, over time you'll get more guardrails. If you had your digital twin, then you'd run it in the digital twin. So yes, it took out the house, but it was just a virtual copy of the house. No harm done. Let's fix that and do it again.
We're going to flag that in the next run. That's right.
Exactly.
Yeah. I do. Finish your thought. I want to talk. I'll come back to constraints.
Yeah. So when you talk about AI in a domain, and then a lot of people talk about validly hallucinations, and these are all statistical. So things that might seem okay don't actually work in this context, and so there's weird things that happen. So we need to put guardrails, but this is guardrails about AI operating in a particular domain.
Sure.
I want to switch gears, so I'll let you.
Okay. No. And for the self-driving network and switching gears, I see what you did there. But so hold that thought on constraints.
Yes.
So I think you're right, and I think putting the effort into providing the correct constraints for an agent that's operating in a context is a necessary ingredient in the recipe. And I do think, there's a combination of things that give us more than a good start there. I know that I'm not allowed to do a request system restart outside of a maintenance window, right? That's a constraint. I know that, a VLAN number of greater than 4095 is not a valid number, right? Not a valid VLAN number. So I have a start for where some of those boundaries are. I also have, my graduate work is in operations research, right? So all about optimization, right? Linear programming, integer programming, find the minimum or maximum value in this constraint space.
Right.
I feel like there's a good start there to okay. And also the whole agent conversation, this is probably another podcast episode. There's a lot of build your own, roll your own agents, and great people are doing experiments publicly, and it's fascinating. It's amazing to see what's happening, and none of it's hardened for enterprise adoption, right?
No.
In large part because of lack of constraints, or not a robust enough set of constraints.
Yeah, the latter. Yeah,
I do. So that's if you're going to do it yourself, that's a burden that you need to accept.
Yeah.
Or if you're going to take a vendor in their platform with their agents, you're going to have to make sure that the vendor has put the right constraints on their agents
Right.
through extensive POC testing and so forth.
Yes.
But I think it's all possible, right? It's just going to take work.
Yeah. So you bring up a really good point. We need constraints and systems of constraints to work with the automation that we're trying to put, or the AI, the agents that we're trying to put in our networks or in whatever application. In fact, I can point you to an article written in 2013 in the New Yorker. It's called Autocorrect, and it recaps the efforts to build self-driving cars up until that point.
Okay.
And they talk about using a combination of machine learning that can actually do a lot of very innovative things, and rule-based stuff, which actually supplies the constraints. So you don't want to learn that you shouldn't run over pedestrians by running over pedestrians, saying, no, don't do that. Do it again. No, don't do that. Yeah. So you just put a rule in place, right?
All right, I have to say this. I've always told my kids, it's great to learn from your own mistakes. It's even better to learn from other people's mistakes.
Yes.
So maybe this is a version of that. Yeah.
Exactly. The other people's mistakes turn into rules, and then you don't have to actually go through that.
That's right.
So that is all when you talk about how do I get productive, safe automation, AI-based, ML-based automation in this domain. The thing that we are even less focused on is the AI itself. The AIs are improving, and you can ask the AI, make my network better, make my gene discovery better, make my whatever better, right? But what if you then turn the AI on itself and say, this algorithm is kind of working, but not really great. Can you make that better? That AI happens to hallucinate a lot. Can you do some analysis and figure out why? And the AI turns on itself. And in doing so, it will be much more efficient, much more, have correct answers better. Great. But what's the end of that? And what's the constraints? What's the rules? What's the guardrails, to use your phrase? That controls that development so that it, in the end, favors the human race, because we're a selfish race. Right. We don't want to be exterminated from the earth. Right. And I think there's not enough effort on that.
Plenty for people to dive into, for sure. And yeah.
Yes.
Well, so much more we could talk about. We should drive this home, as it were. So what's next for you? Like, what big things are you working toward in networking now? Challenges towards getting towards more autonomous behavior. What's encouraged you? You can pick any one or more of those.
Yeah. So I'll pick a couple. One is digital twin, and so I talk about a digital twin at AC0. I had been thinking about it for a while before that. And when I started talking, I realized other people are also thinking about digital twin, network digital twin in particular. And I think my vision of a digital twin is slightly different from others. Others are really saying, I can put up this platform, I can have all these containers, and it's all really good stuff. I am thinking, before I touch my network, every time I would do it in the twin first. Sure. I mean, not the really small thing, but anything of medium to large impact.
Maybe I'll even the small things. I wouldn't exclude those.
Yeah.
Dev, test, and production, right?
So, always, yeah. And so CI/CD pipeline that runs through the digital twin. And I think that will so completely change operations, but actually do something more. It will allow you to experiment in your network.
Agreed.
It will allow you to do things like, I got this network through accretion. There's this acquisition here. There's that thing there.
Placed
this
in
new guy
17 different acquired networks. Yeah.
And this new guy came in and came up with a different idea. And now we've got this hodgepodge. And we're sort of gotten used to it, but it is still hard to manage. So is there a better way to do this? Yeah, there is, but that means changing the config here and changing the, and in the end, that won't actually give us a direct, tangible thing.
Yeah.
So yeah, just leave it. And so it never gets done, right? And the direct, tangible benefit, you usually say that my customer can see. But what about the benefit to ops? Yep. We can all have a much better time operating the network if it was much more uniform and
for sure.
Everywhere, we're doing the same things, we're using the same methods. And so that's just a simple example. You might say, because of the timing of something, we did a bunch of things, but now I could redo them and I could make it much more operationally efficient or much more just efficient in general. You don't do those things because you're afraid. And you say the benefit is there, but the risk is so high. You do it in the digital twin, take all the risk out, and then you come back and do it in the network. But even more so, what if you had a completely different way of doing things? I mean, yes, I've been doing it this way for a long time. It's working. Don't mess with it, right? If it ain't broke, but you don't get innovation that way. You don't have to break the network, though. You go break your digital twin. You break it 10 times, and then you come back and say, whoa, this really works, and it is much better. So I think that that fear, that conservatism we have, which actually is good in a way, because that means that network is so important.
Yep.
If the network weren't important, you'd do whatever.
Right, exactly.
But so it's important, so you want to be careful, but now you're being over careful. You can take that away. So that's kind of what I'm going to focus on for the next year or so.
Cool.
But I also see that digital twin as a means of getting more machine learning into networking, because I can generate data much quicker. I can control the circumstances where the data is generated. So I'm also going to use the digital twin to produce data for my machine learning to work better.
Interesting. So those synthetic data, basically.
Yes.
Yeah.
Yes.
Yep. I think you're spot on. And this is a full circle conversation for me, because I came with that academic background in optimization and modeling and simulation. And when I got into networking, in the real world, I didn't understand why we didn't do more modeling. And our knee-jerk reaction was always, "No, I got to do it in the lab. I gotta put it on the real equipment, right? And I want to see it. I'm going to be from Missouri. You have to show me before I'll even put it in production." And I think there were a lot of dependencies on PFE at the time, and even what was conceptually the PFE, but was also the brains before we did control and forwarding plane separation.
Yes,
But to see this come around and say, now I've finally got something that really lets me holistically model, what's happening, in my data center fabric and my whole network. Yep. Yeah. I would love to see you push the challenge beyond the network digital twin.
Yes.
Because I do think this next quantum leap for systems optimization is going to require spanning those domains. And, now as part of the broader HPE family, you're in a different position now where you have access to resources and developers that you can take a bigger picture view. So rise to the challenge.
Yes. So I will say this, when I talked about a self-driving network in 2015, 2016, none of this stuff that we have today was there. ChatGPT, LLMs, really, really large models, agentic AI. It's almost like you take a leap of faith and say, technology will move forward. here's a real problem. We are operating our networks manually. We have some technology that should help us do a little less of that and a little more automation. But there is this other stuff happening. So why don't we look there? And if you don't look there, you never get there. And so I think that's the kind of thing we need to keep doing. And we need to keep looking, whether it's the network, that's what we do, or whatever other field, and have that sort of bold, this sounds, I mean, in 2015, when I had this, people were saying, sounds really nice, it's completely unimplementable, completely crazy.
Well, only 10 years later. Yep.
Yeah. So I'm with you. I mean, I'm going to continue doing that. I'm going to continue. I mean, digital twin is a means to getting to the next step, and maybe it'll open a window for us that when we peek through that, like, oh, we should be going there now.
Yeah. I'll be interested to see what you see through that window.
Yes.
I just want to express my appreciation for you coming on here today. It's been great to stay, in light touch over the years. And, I'll just embarrass you a little bit by, you mentored me informally. You led by example. I've always appreciated who you were and who you are. And I'll say, being able to participate in the Distinguished Engineer program at Juniper as this field guy who's just trying to sell stuff. The elbows I was able to rub there and the intellect cumulatively that I was able to learn from and have interaction with was one of the highlights of my career. So thank you for everything you did there. So
that's so very kind of you. And I will say that for me, what really got my career moving in a different direction, a better direction, was interaction with customers. And it was people like you who helped mediate that. And I mean, the initial customers were one-on-one, but later it was through folks like you.
Yeah.
And the interaction, just talking with you, and thank you for having me on the podcast. It's always energizing. It's always, something comes out of it, and maybe not today, but in a week, in a month, I'll say, hey, you remember that? Let me go back to that and see if that goes somewhere. And so those sparks start, you don't know where, but it's these interactions that are the starting point for that. So thank you.
Thank you. And you know how to get a hold of me. If any of those sparks light a flame, let me know. Where can folks find you? Are you putting stuff out there? Are you a LinkedIn person? What's the best way to see what Kireeti's up to?
So the only social media I do is LinkedIn. So you won't find me anywhere else. I do watch my LinkedIn, not necessarily as often as I should, but I did come up with a technology that I want to get out there more. So I want to do a series of blog posts on LinkedIn about this technology. It's called Multipath TE.
Okay.
And so people will see me active on LinkedIn a lot more. You can find me on LinkedIn, and you can find me at my email, which is now conveniently kireeti.kompella@hpe.com. If you replace HPE with Gmail, you will still find me. It's just one is my work persona, the other is my private persona. I just want to both.
Got it. Well, thank you again. You put that out there. I bet you get some hits on that. So excellent. Thanks for being here today, Kireeti. For all you operators listening in, thanks for spending more time with us on Total Network Operations. You know that we're here on Packet Pushers. We have lots of other great shows for you to benefit from, like Heavy Networking, like Packet Protector, like Network Automation Nerds, and more. We love to have people just like Kireeti, who has better things to do with his time, but is still willing to come and have these conversations and get us thinking about important things in networking. So thanks again, Kireeti.
I'll just say this. I don't know if I actually have better things to do, but I do not have funner things to do. So thank you.
Well, we've added to your fun quotient. If you've had fun listening, we'd love your feedback. You can also hit me on LinkedIn via DM, or you can send us follow-up at packetpushers.net/follow-up. Thank you again, and we'll see you next time on Total Network Operations.